Good morning. Just had a wonderful watch on the Terry Fox Assembly video. It was awesome. Mr. Adam has never looked so good on the drums. It's crazy. And Mr. Knight with this collection of guitars was just fantastic. So hopefully you guys could take a look at that. So we'll continue with the learning. Make sure you watch these videos. I think some of these videos will help some students with understanding. So hopefully you guys are watching and keep going with it. This is the first day since March 13th I actually wore teacher clothes. That doesn't mean that I just fit in them, but hey, whatever. So hopefully you guys are staying well, stay safe, and we'll kind of give this a go. So what we're going to take a look at today is we're going to take a look at linear relationships and looking at word problems. And we're going to look at descriptions, and hopefully over the next few minutes here, you'll have an understanding of how they are all connected. So we're looking for some key words, how to identify the rate of change and the initial value. And hopefully we can interpret their meaning when it's written out in words. If we can do that, I think your understanding of it will be a lot clearer as we move forward. We're going to be able to make a linear equation, and we're going to be able to make different connections. All right, so with that said, let's take a look at the first question here. To order a supersized sundae at Northwoods Ice Cream Parlor, it costs $5 plus 75 cents per topping. If C is the total cost of the sundae, and N has that many toppings on it, complete the following table. So when we're looking at rate of change and constant, we're looking at what each part of the equation is doing. And we can look at that is the toppings is changing the cost. So for every topping that I'm putting through, all right, so when you're looking at here, this is my unit rate of change here. So my rate of change is $1.75 per topping. So that's what's changing. Okay, so to kind of put that in words, I could make a sentence out of that by just saying, all right, the meaning of the rate of change is the cost per topping is 75 cents, or another way of looking at it, it costs 75 cents per topping moving forward. So we want to emphasize we're making the connection to what part of the equation is which. All right. Now, my initial value is $5 because that's what I start with. This is my base cost. All right. Or some people would say this is my fixed cost. This is my changing cost here, this side. Okay. So what that means is it will cost $5 with 0 toppings or no toppings. All right, the idea there is I have no toppings, that's what it looks like. Okay, so from there I can make my equation. So kind of going back to before, we have C equals MN plus B. This is my M, this is my B. So the equation would look like so. Because the N is the number of toppings, we're multiplying the number of toppings by 75 cents. So hopefully that's kind of making that connection, all right? But it's based on the wording of the question, so be careful of that. All right, now to determine the cost of a sundae with 5 toppings, we know that N is 5. We can now use our equation, my original equation here, and I can substitute that in. All right, because with 5 toppings, we would take that 75 cents times it by 5, And we know that if I use my calculator, all right, I get that. All right, so now I know that it would cost $8.75 $8.75 for 5 toppings on my sundae. Done. So that's the connection that we're trying to make today, is how do we know what the rate of change is? How do we know what the fixed cost is to make the equation? The meaning of those two things is what's driving that equation. So keep that in mind as you're moving forward with that learning. All right, let's probably make some connections to the next one here. Wilson's taxi service costs $5 to get picked up, plus an additional 80 cents per kilogram. All right, so just from that sentence, hopefully we can say what does each number make a change? Which one is the cost that is fixed? So this has to be my fixed cost. And this is my changing cost, or my changing number. So take 5 seconds, write down which value goes into which, and I will come back after the break and show you. So hopefully you wrote down 80 cents per kilometer. So we're comparing two variables, cost and kilometers, and it's going to be $5. This is my fixed. So hopefully if I write my equation down, my fixed cost goes with N plus my $5. Okay? So what I'm going to do is I'm going to push pause. I'm going to type in here. What I want you to do is you push pause, and I want you to try to write down what the meaning of each of those letters mean. And there's different ways of writing this too. So I wrote down it costs 80 cents per kilometer driven. All right, so that's the amount that's changing here. And the initial cost is $5, is the amount of money paid at the start, so at 0 kilometers. Two different ways of writing that compared to at the beginning. All right. And now I can just use my equation to answer my equation. I have C equals 0.80 times my 15. So I'm substitute N equals 15 into my equation. All right. And then I can evaluate that. So if I went 18 kilometers, 15 kilometers, it would cost me that $12 for the 15 plus the additional 5 for the fixed. Okay, so my total fare for that day, or that driven, would be $17. So the total cost for a 15-kilometer taxi ride would be $17. All right, so keep that in mind as you're doing some of these things. The words is going to help you with understanding the meaning. All right, Cameron has $7,500 in her savings account. She spends $600 per month to rent a room for college. If A represents the amount of money in Cameron's savings account and N represents the number of months, complete the following table. So sometimes it's easier to find how much she starts with. So my initial amount was $7,500 because that's what we start with. Okay. The second part here is she spends $600 per month. So when you spend money, all right, which my wife is really good for, all right, the amount of money decreases. All right, so actually the rate of change is actually negative. All right, because she's spending $600 per month, the amount of money that's in my account decreases by $600 per month. So that's where that meaning helps out with. All right, she spends $600 per month on rent, which makes this a negative rate of change because she's spending it. All right. She started with 75. Let's try that again. In her account. All right. So when I make my equation, all right, we have to make sure that we include that negative value in that. So when I write that down, it's got to be negative 600 and plus 75, because we want to show the decreasing part. All right, so that's why that's negative. Okay, so when I put in my value in for n equals 8 here, all right, negative 600 times 8 plus 7,500, it will show us that we're decreasing by that much money. So 600 times 8. So this is negative 4,800. So that's how much she spent. And then we're going to subtract that off. All right. So after 8 months, she will have $2,700 remaining. So after 8 months, she will have 27 remaining in her account. All right. So what the graph of this would look like, if I was going to do a really quick sketch here, is I would start up here at 7,500 and it would be decreasing. All right. That's what that looks like. So hopefully you understand that moving forward. All right. Positive slope should be increasing. This is a negative slope. All right. So sometimes we could give you the equations and then we could talk about what do they mean. So the equation below represents the relationship between the mass of the block in grams, m in grams, and the amount of time. So I'm going to put that amount of time since it started in t in minutes. All right, so if I was going to graph this, all right, we know it's melting. All right, we could look at this and say, hey, here's my fixed cost, or where I start with. So we're going to start off at 55, and we're going to go down my slope. So this is my slope number. All right, my slope, how I identify my slope is attached to a letter. All right, so my initial value is 55. And what does that mean? Well, I initially started with 55 grams of ice. All right, because that is the y variable, that's the vertical line from that. My units here is what's happened to this ice. Well, it's decreasing grams per minute. And the reason why I know that is because if I drew a graph, this is what it would look like. And my slope is rise over run. Well, I know my slope is grams and minutes. So it has to match the graph. Okay. So the meaning of that is the initial mass of the ice cube was 55 grams. This one, that -5, is the ice is melting at 5 grams per minute. So we're kind of twisting around by giving you the equation versus not, okay? But that's kind of what that rate of change versus the initial value is, all right? 55 is by itself, doesn't have any letter it starts off with, okay? -5 is with the variable t, and that's what's happening there, all right? And this is melting, all right? That makes this a negative slope. Right? Or the ice is decreasing at 5 grams per minute. You can think of it that too. Okay. All right. So hopefully you're understanding some of the things that increases versus decreasing. Sometimes the graphs help you to understand the connection. All right. By drawing this graph here, based on this graph, I can interpret those informations. All right. So a pizza store charges a price for a medium pizza plus an additional cost per topping. So here we're adding on, add cost per topping. So what I want you to do is try to do A and B by yourself, all right, and write it down and then come back and check your answer and see if it makes sense. All right, so we're back. So where I got that from is this 8 here is my initial value, all right, because there's no variable attached to it. That's where I start off with. That's my fixed cost, that type of thing. And this 1.5 is my rate of change based on it's attached to n. And just so that we have 2 decimal places for money, that's what I kind of look at. Okay, so it's changing by $1.50 for every topping that I add on. All right, so we're interpreting the equation by looking at the constant and the rate of change. So that's what we're implying today. All right, so if I was looking at cost for 4 extra toppings, I know that n is 4. So if I look at this, I can sub in n equals 4 into that. So 4 times 1.5, that's 6. All right, then that's going to cost me $14. All right, the cost for medium pizza with 4 toppings would be $14. Done. Okay, so the big goal here is interpreting the equation from the slope and the y-intercept, or finding the y-intercept in the words to make the equation. So we're kind of going back and forth and making that connection. That's the goal. All right. All right, this should be the last example, I think. Yes. All right. So Thomas is selling chocolates to raise money for hockey. The total number of chocolate bars has left in cell R is related to the number of days he has spent selling them from door to door by the equation. So one of the first things we want to look at is what are the 2 things we're looking at? All right, we have chocolate bars left R, and we've got days in n. Okay. If we look at this, we're going to have these 2 variables. All right. So my initial value has no variable attached to it. All right, so initially I had 120 chocolate bars based on the equation. My rate of change is -5. Okay, so the meaning of that we can interpret. This is where we, all right, he had 120 chocolate bars at the start. All right. All right. All right. He sold 5 chocolate bars per day because those are the two variables that we identified there. All right. That's what we're looking at. So we should be able to make those connections. All right. Last part here. All right. Now, my question to you is, should n equal 2? Okay. Well, remember, n equals the number of days. All right. Because it says up here, if I just scroll up just a little bit, to the number of days n. N has to be the number of days. N has to be 14 days. Because the units have to be the same. Okay. So now I can use my equation. So I have 120 minus 5n. C equals 120 minus 5 times 14. I have no idea what 5 times 14 is. Actually, I probably do, but I'm going to make sure it's right. It's 70. All right. So we know that you'll have 50 chocolate bars left. There we go. All right. Ooh, this is interesting. Amanda has a snow shoveling business. She has to spend some money on advertising. When she shovels 4 driveways, her profit is $480. When she shovels 12 driveways, her profit is $1680. What amount of money does Amanda make on each driveway? So when it says amount of money, all right, one quantity comparing another quantity, we're thinking rate of change. Now, we don't have an equation, but we can make a table. All right, so we know that 4 driveway gets you $480 or $48, and she knows that 12 driveways gets her $168. Well, how do we find rate of change? How do we find slope? All right, well, we know that slope equals rise over run. So this goes back to previous learning. So our previous learning says my rise has to be over here, my run has to be over here. Okay, so I can look at that. All right, let's look at 8 and 168, subtract 48, that leaves me 120. I can take those numbers and substitute them up in here. 120 divided by 8, and that's driveways. All right, so I can take 120 divided by 8. That means she charges $15 per driveway. All right, all by finding the slope. If we didn't know what the slope is, we can find the slope from 2 points. All right. So Amanda charges $15 per driveway. So that's my rate of change. Ah! Okay. What's her advertising cost? Well, this is going to be my fixed cost. All right. So if we looked at this, and if we go back to our table here, and I'm going to go back up to here, we know that $4 gets you $48. And we need to go back to 0. We're going to subtract by 4 because we know that. Well, the question is, what do we have to do to go back? Well, we know it has to be 4 times my rate of change because we've done 4 steps back. So 4 times 15, that's going to get you 60. So she's actually in the hole $12. Well, she had to spend $12 at the start. That's why she's in the negative. Okay. She spent $12 at the start. And this is actually a negative number because we've spent it. Okay. So this is money that's going out. All right, it's not money that's coming in. Profit is money that comes in, or the total money. All right, so if I'm looking at this, P equals 15N minus 12. All right, so if I'm looking at that, all right, there's my rate of change. And this is my fixed. But remember, that was money spent. All right, so she had to subtract off the money spent at the beginning. Okay? So hopefully that kind of makes sense when we move forward. All right. So the big ideas here is, I can identify a linear relationship from a word description. Check. I can identify the initial value, the rate of change, and construct a linear equation from that description. I can interpret when it's necessary to have a negative rate of change. So negative rate of change is when it's decreasing in value somehow, because it's decreasing at a constant rate of change. Would have been helpful if I actually finished reading that sentence. I understand that a word description, an equation, a graph, and a table can all demonstrate the same linear relationship. They all mean the same thing. And if you have to draw a graph to help you understand it, great. If you can see it as equation, great. It doesn't matter. So hopefully that's helped you today, and give the practice a go, and we'll talk to you later.